I know you've heard of hypertension and maybe thrombosis, but hypertension is high blood pressure. Okay. Uh, Usually we'll get to it later, but that means 130, 140, something like that. And thrombosis is a blood clot. So why is not writing? Okay, so clot of blood. So atherosclerosis, um, basically caused by plaques. That's something you've probably heard of. So plaques get built up on the inside of the arteries, and what a plaque is, a collection of fat or cholesterol. And like I said, fancy word is thrombosis, the clot, and that basically your red blood cells caught up in the plaque. So, and maybe I should write that down. Don't want to abbreviate too much. Make it less confusing. It's high blood pressure, even with my handwriting there. So if you have a big clot, a thrombosis in your artery or vein, you're going to have a blockage of your blood flow. So you're not going to have blood flowing through, which is a big problem, as you might think. And that can lead to, if it's in the blood vessels, the coronary arteries, that's going to lead to a heart attack, because no oxygen, no action of the muscles in your heart. It's going to stop pumping. So remember, it's not your heart going crazy, it's just stopping because there's no oxygen. And then hypertension, this high blood pressure, narrow and stiff arteries. You may have heard of an aneurysm, but an artery gets weak and then bursts, and that obviously is a problem, especially if it's internal. External bleeding obviously is easy to see, but if you have internal bleeding, it can be worse, because by the time you know there's bleeding, you could be passed out and on the way to death. Down here, stroke. Okay, from that high blood pressure, rupturing blood vessels in the brain, and kidney failure. Kidney, those glomerulus right here can be really sensitive to high blood pressure, and if you're getting too high a blood pressure, it gets damaged, or the artery into the kidney gets damaged, and you're going to need a kidney transplant. So there's a nice little graphic. I like this here showing electron micrograph. It looks like little hairs, or just this net grabbing all these red blood cells, creating that clot. But here we have this buildup, this plaque, and it's covered with a cap. And that video we saw with John, it really did a good job at animating this. And then eventually there could be a disruption of that cap, rips it open, and then you have this this clot form. So cap ruptures, and then this blood clot forms. So boom, and you can see this arrow here, handy. Oh, try to go this way, can't go. And that happens here. Say this is happening in this artery. You see this blackened area. This is dead tissue, and it's not going to come back. I don't think heart tissue regenerates, so it's always going to be there. What's great, pretty cool though, your body can build new blood vessels as need be, to a certain extent, and it can repair that damage if you give enough time. It's usually just very suddenly that you have, if this happens slowly, your body will just build a new vessel. But if it's quick, it's obviously not enough time. And this is a nice little graphic. So this is normally, it should be about right here. And all of this stuff is plaque. So why don't you annotate this on your slide. That's all plaque. Oh, look at all that. Look how narrow that opening is. Versus over here, a healthy artery without it, you don't even see any plaque there at all. And obviously much better for you to have that flow. So we can measure this in a lot of different ways. Types of exercise. We've had, I think, some people in the past or now compare different, like running or jumping jacks, weightlifting, see how it affects heart rate. Also the intensity of exercise. By going hard, what kind of an effect does that have on your heart rate? Recovery, stopping exercise, seeing how long it takes your heart to recover. Relaxation, if you get real relaxed, does that affect your heart rate? Like a breathing exercise. I have breathing here, so I should put that. Breathing. When I have some techniques that I do, if I feel my heart rate getting high because of stress with breathing, it'll help bring it down. Oh yeah, here it is, right here. I think this is the next one. Breathing. Anything with breathing and breath holding, I'll get to that. We did an experiment on that. Exposure to cold too, and facial immersion in water. This is, I wish we would do this. Maybe we will. The vagus nerve. If you stick your head and your face in cold water, it should slow your heart rate. Most mammals show this. It's kind of like a diving reflex. Most mammals will show, for some reason, even though we're land animals, we have like a diving reflex. That's crazy. It's amazing. This is a previous lab we did. Hopefully this will ring a bell. When you take the exam, you should really be digging. All the labs we do come from what IAB expects you to be doing. So usually that means it will show up on an exam. But if you remember, this was the normal. We had you just breathe normally for 30 seconds, and then I had you hold breath at this point, and then this is that you breathe normal, and we were trying to see if there was a difference in your heart rate, and this would be the recovery. So we're testing a couple different things, breathing and recovery with that one. So whenever you see blood pressure, you see one number over another. Okay, that's your systolic on top. That's the maximum. That's right after your, or when your ventricular atria are contracting, measures that pressure. And the diastolic measures kind of the resting, when right after your heart relaxes, that lower pressure. So systolic is on top, and diastolic is on the bottom. And I don't know what that number down there is. I'll just say it's 80. But usually you see it one on top of the other. But systolic and diastolic pressure. And here we go. So normal is less than 120, or 120. I don't want too low because that's a problem too. Elevated would be 120 to 129. And this is the systolic we usually focus on when it comes to blood, because that's that maximum pressure that's really putting the strain on the arteries. Although for diastolic, you don't want it too high either. If it's too high, it means the arteries are hardened and they can't relax enough to loosen up to let go of that pressure. Arteries are too hard. They're not flexible. You may have heard of fish oil. People take fish oil supplements for blood pressure moderation or management. Supposedly, that fish oil helps to give a little more give to the arteries, the blood vessels, and reduce inflammation, which can increase blood pressure. So, continuing here, 130 to 139 is this stage 1 hypertension. So really, once you start getting into 130, that's when you have high blood pressure. And definitely 140 plus puts you into stage 2. And a crisis would be if it went above 180. Okay, that's a major issue, and you would feel it. But monitoring blood pressure, that's one of the main things that a physician, it's not invasive, it's easy to get, and it can tell you a lot about your health. So this is pretty cool. This is how the blood pressure cuff works. So what they'll do is they'll put on this cuff and then they'll pump it up so the blood is occluded, which is a fancy way of saying it's blocked. So the blood is blocked. You can see there's no blood getting through here, no flow. That means there's no pulse. So they'll put a stethoscope there, pump it up till they can't hear anything. Then they'll gently, so release slowly the pressure until they can hear it. And once they can hear it, it's actually, you can kind of hear the rush of blood start to go through. That's that middle point where once it comes through, you know that's the pressure that that blood vessel is under. And then when they'll keep listening until they can't hear the pulse anymore, then they'll determine that's the diastolic. Or it's kind of hard to see there. Diastolic. So it's blocking the flow and first hearing the flow come back, and then not hearing. Just to kind of sum it up. It's pretty cool. Yeah, I get that. I haven't done that in a while, but it's pretty cool to hear the blood rush through your artery like that. I think it's kind of a kick. So very cool. I love these EKGs. You see the systole of the atria. So the atria, the top chambers. If you remember, systole. So that's that high blood pressure. You see, boop, the atria contracting. So the atria contracting. Okay, you can see that in this P wave. The Q point is when the AV node sends an impulse. Where's my thing? Never really got used to my new pad. I need to replace my last one with the same model. So the AV node sends that impulse, and that QRS, you see where we go Q up to R up to S, that's the ventricles, ventricular systole. So it's contracting. So here are the ventricles. The ventricles contract. And you see, it's terrible. And you'll see it's much bigger, isn't it? Well, why is that? Why is it so much bigger? Think about the size of those chambers. The ventricles are much bigger than the atria, so they're generating a lot more electrical force there. So you can check out a lot of things. This is the normal EKG. It's evenly spaced. See, boom, 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 boom. You got the normal, you got the P wave, and then the ventricle, got the atria contracting, the ventricles, and then you have the repolarization. So that's good. What do you notice here with bradycardia? 1, 2, 3. Up here there's 4. It's too slow. That's what Brady means. That's definitely probably Latin for slow. Or Greek. Down here we have atrial fibrillation. And remember that atria is that little one before, and here they're all, it's just a whole bunch of them. It's not organized. You still see the ventricles contracting. So that seems to be happening fairly normally, if not too much, but those atria just are not, it's just not working very well. And if you work over here, you'll notice boom, boom, which is normal, and then a long pause, and then boom, boom. So this is called arrhythmia. And this, you'll see, it's not regular, so irregular. That's irregular heartbeat. And I think you've all heard of that. Irregular heartbeat, arrhythmia. Go to the next one. Boom, 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 boom. We got the normal. It's the normal bumps that we see, the normal electrical impulses, but it's too fast. That's called tachycardia. Too fast. It's a racing heartbeat. That's what I have when I do my breathing techniques. Slow that down. Well, I breathe in, hold it, maybe 5 seconds, then breathe out. You notice that just really relaxes you. You should try it. Tachycardia. Tachy is probably Greek or Latin for fast. Gotta look that up. Pause. Check out Google. And down here you'll see there's a bunch of wild bumps. This is ventricular fibrillation. You'll see it's different than it's just fibrillation, but it's a different kind. You see, because the ventricles are so dominant in their electrical output. So ventricular fibrillation. Ventricular fibrillation. Okay, epidemiology, very important. I love epidemiology. Not just saying it, but thinking about it. It's pretty cool. So damage. They want us to look at coronary heart disease. So this would be any kind of damage to the heart. To the heart as a consequence, reducing the blood supply, narrowing, hardening, or a gradual blocking. And there's a lot of research gone into this because it wasn't a huge killer of people until about 60, 70 years ago. So it was a big push to see what was going on with it. So it's a lot of decent research into it. I wouldn't say fantastic, but looking at ethnic groups. This is tough to study humans in general, no matter what you're looking at. Different ethnic groups, although that's kind of unclear. Gender groups, males tend to get it more, but women do still get it at a pretty high rate. So it's kind of unclear what's going on there. Age groups, normally older. Different physical activity. Is it physical activity or body mass index or weight that's really driving it? That's not always clear. Groups, different genotypes. We talked earlier. The genetic component of heart disease and stroke is a really powerful effect, and different medical history. Epidemiology, patterns. Looking for patterns, trying to identify causes and different effects, okay, in different individuals. That's what we're looking at with epidemiology. So IB will probably give you, something similar to this. They will on the exam. So cardiovascular disease attributable to behavior risk factors like tobacco, not doing anything, things you eat. Okay, and so remember, always look at the x-axis. Okay, you probably understand those things. You'll see there's different bars. The global average, which is really important when you're comparing. Then India, United States. So we're trying to look at that. And we have DALYs per 1,000 people. That is disability adjusted life years. Basically, that means number of years lost because of early death. So it's not good. You want that bar low. Basically, the higher it is, my dog's going crazy. The higher it is, that means you're losing years to this to disease. So a question they might ask you is, which seems to be the biggest impact? Tobacco, low physical activity, or dietary? And you look over here, it's pretty overwhelming. This dietary risks is the biggest impact on early death. And the second one would be tobacco. Tobacco is just, they've studied it for a long time. It just makes you sick and makes you die early. There's just nothing to discount that, although the tobacco companies really tried. If you look at this, it might ask you, has there been progress in the global number of years lost because of tobacco? And if you look, it does go down between 1990 and I believe this is 2008, I think. My face is blocking it right now, which isn't bad. That's 20 years. Wait a second, 30 years worth of data. So it goes up by 10 each time. So that's pretty good. What about physical activity? You'll see it's a pretty low, and we're pretty similar to everybody's similar, India and United States, to the rest of the world at the beginning. But you'll see India shows a higher risk. So maybe you might say, as an effect of the information you get by looking at epidemiology, they should look at physical activity, increasing that in India. I still can't believe our number went down. So, for the United States, so maybe, according to this, we have increased physical activity. And one thing about tobacco lately, I really can't, I'm kind of worried because of vaping changing our progress on this worldwide and United States. So make sure you can check out graphs like this and glean information from them. Here's another one we can practice with. Basically, again, coronary artery disease mortality, looking at urban males, urban females, rural females. And one pattern might ask you, it might say, what is the difference between urban and rural living? And if you look at the two lowest lines, those are the rural, so they have lower. If you're urban, it's higher, so rural, you might say rural people have lower risk of, sorry about the handwriting, coronary heart disease. Maybe I barely drew that, wrote that legibly. So rural people, you can see they have that lower incidences. In both cases, you'll see females are lower risk in either area. However, if you look at urban females, they're still higher on average than the rural males. Okay, even that females have that lower risk. If you put them in an urban area, they're going to go higher. They're going to increase by quite a bit. Like if you look at just kind of measure that space, it's pretty similar for males and females. If you'll see 140 to 80, so 40, so 60,000 was like a 60,000 per 100,000 a year increase, and that's pretty much similar to both males and females. So practice on those, make sure you can read those and get information from them.